Okay, so today we are going to study about conditional structures in Python. And please remember, the conditional structures basically means to provide with a certain condition. So far, whatever programming you had been doing involved certain number of mathematical calculations. But programming doesn't involve just only mathematical calculations. It also involves, certain, conditions where we need to check for a certain logic and filter out, data depending upon that particular condition, whether a condition is resulting in true or false, or yes or no. Either way you can tell it either true or false, or yes or no. And remember something, that conditional structures is also named by conditional statements. All these names, conditional structures, conditional statements, conditional constructs, all means the same thing in Python. And remember, we'll be learning few new keywords like if, else, elif, all these statements, is, and different type of operators which are involved with the conditional structures. Okay, then I believe we are all ready to go for the first concept. Now here, what is written is the definition for conditional statements. And you can see conditional construct or statements are those statements that allow us to check a condition and execute certain parts of code depending on whether the condition is true or false. So here you will have a certain condition, and depending upon the truthness or the falsity of a particular condition, a certain statement will get executed, otherwise another set of statement will get executed. So for the first time, instead of having statements which are sequentially executed, that is one after the other, so far you had been doing that sequential statements where execution was happening one after the other. Out here what is happening is, depending upon a certain condition, a set of statement will get executed, and if the condition is do not get satisfied, another set of statement gets executed. Okay, now let's jump into it. Now look at the first statement out here, the if statement. We are going to learn the different type of conditional statements in Python using this. So the first thing out here we are going to learn is if statement, and remember the keyword if. Here I'm just underlining this. The keyword if is basically a keyword, so please remember that this keyword cannot be used for any variables. I believe you remember. Similarly, we have if-else statement. So both if and else, of course the elaborate discussion will be later on in this particular video itself, but first of all please understand that these two are keywords, so you cannot use it as a variable. Similarly, we have if, elif, and else statement. So again, these three are keywords. So whatever I'm underlining out here, they are keywords and cannot be used for anything else other than what it is intended for. So you cannot use it as a keyword. So far we had only learned how to use variables. So these keywords cannot be used for defining variables. You cannot have a variable if equal to 5. You cannot write that a equal to 5. You can write I may be capital in if, that will be considered different, but not this keywords with all letters small. If, else, elif, these are all keywords. And then the fourth one you can see over there, nested if statement, that is if inside another if. And then we have conditional expression, a concise way of defining if else statement. Now we are going to start with the if statement. Now you can see what an if statement looks like. You can see over there, if is the keyword followed by the test expression. Now please remember, this test expression consists of certain condition, and if this condition gets satisfied, whatever is written out here, this particular statement or group of statements will get executed. Now point to be noted, it is intentionally this particular area, you can see over here, this particular area is kept indented. That means slightly these statements are kept inside. This is to indicate, this is Python's method of indicating that this particular statement or group of statement belongs to this if statement. What does it mean? That means if this test expression, remember a test expression or a condition in Python will either result as true or it will result as false. So if the test expression results as true, whatever you write within this indented block out here, that means leaving a little bit of space at the beginning and you start writing out here. So from here onwards, whatever statement you write will get executed if this particular test expression results to be true. And the first unindented statement it comes across, it understands that this is not inside the if block. This will anyway get executed. I believe you can understand what I'm trying to tell over here. Okay, now we are going to see an example related to the if statement. So here you can see a small program has been written over here. Now let's look at the program. What does it tell? A is a variable where I'm taking an integer as input. And here you can see the test expression over here. If is the keyword as usual. A is greater than 50. Now please remember, A greater than 50, this is a test expression. This will either result as true or it's going to result as false. So any statement which you write over here will result either as true or it will result as false. And if it is greater than 50, what have I asked the computer to do? Now see over here, there are two statements over here. You can see over here, the first one is print and the next one is another print, and both are indented. This is to tell that if this condition is true, these two statements will get executed. And the first non-indented statement is this. That means this print, I'm just underlining this particular print statement will get executed irrespective of whether the condition is true or false, because this is unindented. That means it is not a part of this if block. Whatever indented statements you have, it means it's a part of the if block. If block in the sense that this particular block gets executed when this condition is satisfied. And this print, that is the first unindented statement, will get irrespective of whether this condition gets satisfied or not. Now, if it gets satisfied, it will print all these two statements. Along with this, it will print this. And if this condition is not satisfied, it will not print this two statement. It will directly jump over here and print this. Okay, we'll see the execution of this program. So you don't need to worry much how it will look. Okay, now let's try this in the Python ideally. On the right hand panel, you can see the program I've written, and here on the left hand panel is the interactive mode or the shell. I believe you remember. Here you'll see the output of this particular program on the right hand side. The right hand side program is the same program which we had just seen currently. Okay, here what we are doing is we are taking a number as input, and if this condition is greater than 50, as I told you, it's going to print these two statements. That is, it is going to print good and we think alike, and this statement anyway will get executed irrespective of if this condition is true or false. Let's try executing it. Okay, let's execute it. Okay, now we executed it, and let me input the number 12 into it. Now, you see, if I input 12, now look at the program. If A is greater than 50, now 12 is not greater than 50. So what happens? This two statement, that is print good and print we think alike, it doesn't get executed. Instead, it comes to the first unindented block, and out there, it will simply execute whatever is written over there. What is written over there anyway will get executed. So it got executed over there. Okay, let me run the program once again and see what is the output. Okay, let me run the program. Okay, once again we got a number. Let me input a number, say for example 65. And yes, you can see the first statement, that is good and we think alike, these two statements get executed. So first good gets displayed and then we think alike gets displayed, and the last statement, that is anyway will get executed, will get executed irrespective of whether the condition is satisfied or not. So I believe you can understand what is the meaning of if statement and how we provide with a condition. And remember, this particular condition, that is A greater than 50, this is technically called test expression. Okay, and remember that this particular test expression will either result as true or false. I can just show you an example. Say for example 25 is greater than 12. I can always write this as an expression. You know, this is a test expression, and you can see what is the answer it gives me. You can see over there the answer is true. And note that this is a Boolean value. We consider this to be of Boolean type. We can even store it into a variable. So such variables will be considered to be of Boolean type. And remember, this true's T will be in capital. Please remember that. And as similarly, if the condition is not true, it will result as false. So here I have written a statement 25 is less than 12. It will result as false. And remember, the first letter of the word false is once again, capital. So remember, in an if statement, we will either have true or we'll have false. And the true and false always results from a certain condition. The condition if satisfied will be resulting as true, and if this condition is not satisfied, it will result as false. That's it. You need to understand that a test expression always results in either true or false. Now we'll get back to the next conditional construct which we are going to learn after the if statement, that is if-else statement. Okay, here comes the if-else statement, and you can see over here in the if-else statement, the name itself tells you everything, that out there we had only if statement, and the if statement basically means if the condition is satisfied, it does in the sense that it executes a group of statement. Whereas in if-else statement, if the condition or the test expression here, let me mark the test expression, if the test expression gets satisfied, that is if it results to true, the statements inside this block, that is if block, will get executed, and if this test expression results to false, the statements inside the else block gets executed. And remember, these two blocks are again indented, and remember, this indentation is necessary to indicate, to tell Python that this particular group of statements belong to if and this particular statement belong to else. And remember, else should always be preceded with if and its corresponding statements. You cannot have an else block without an if, or you cannot exit from a if block and you can write else over there. No, nothing of that sort happens. You should always have an indented block of the if block followed by else, and which will have statements again which should be indented. Now look at the example at the side. So in the first line, what do we have? It's taking a number as input, an integer, and here what are we doing? We are checking whether the value of a is greater than 50 or not. If it is greater than 50, it's going to print good, and then it's also going to print we think alike. And after this, what is going to happen? It'll directly jump to the first unindented line. So this will be the line where it will jump, and it's going to display print anyway, it will get executed. So after good we think alike, if the value of a is greater than 50, it's going to display this to message, along with that anyway will get executed. Similarly, if this condition do not get satisfied, so it will directly jump to the else part, it will print bad, we do not think alike, and then again it will execute anyway will get executed. So I believe you can understand that both if as well as else block, either way, after executing itself, depending upon the satisfaction of the condition or non-satisfaction of the condition, it will next execute, that particular program will execute the first unindented line of code, which means that it do not belong to either if or else. It will anyway get executed. So we are going to see the execution of this program in the Python ideally. Let's try that. Okay, the same program in the Python ideally. Now what we are going to do is we are going to run this particular program. Let's try that. Run. Okay, and now let me put the number 75. So what do you think it's going to give you? It's going to give you the word good, we think alike, along with that anyway will get executed. Let's see whether it gives that or not. Okay, good, we think alike, anyway will get executed. So we got as expected. Again, let me run the program. Okay, let me run. Okay, this time let me give the number, say 34, which is obviously less than 50, and therefore the else block gets executed. So what is the output we are going to get? So it is going to display bad, and then it's going to display we do not think alike, along with that anyway will get executed. Let's see whether the expected output will be like that or not. Oh yes, we got the same output, bad, we do not think alike, and then anyway will get executed. See, in both the situations, anyway will get executed. I'm just highlighting this line, anyway will get executed in both the cases, irrespective of if the condition is true or the condition is false, gets executed, because this is the first unindented line of code. That means it do not belong to either if or else. It is simply a sequential statements which will simply get executed irrespective of whether the if got executed or else got executed, and all subsequent lines below it will also get executed, please remember. And it is not necessary that you have to give a unindented line at the bottom of if and else. Don't get misled. This is just to tell you that it will carry on after executing the if and else. It will carry on normally executing, like the way you had learned. It will carry on executing. You may have this line, you may not have this line. If you do not have this line, it will anyway end either executing the if block or executing the else block. It will definitely end. And if this line is there, well and fine. After executing either of these blocks, that is if block or else block, it's going to get executed. I believe you can understand this. Okay, now let us study in a test expression. You have already seen the greater than symbol. Those are called relational operators. Relational operators that you can use in Python are, you can see over there, greater than symbol, you have a greater than symbol, then you have less than symbol, then we have greater than equal to symbol. In mathematics, we write this as this greater than or equal to. Please remember that it means greater than or equal to, and then we have less than or equal to. So in mathematics, we write it this way: less than or equal to, and then equal to equal to. This is equal to is used to indicate equal to. Now, suppose, say for example, you have something like that. Say for example, a equal to just a single equal to, say for example, I write 5. So a equal to 5, what does it mean? This means assign the value of 5 to a. That means give the value to the container a or the variable a. But when I put 2 equal to, that means this becomes a this becomes a test expression. That means it is asking the computer to check whether the value of a is equal to 5 or not. So please understand the difference. If it is single equal to, it means assign the value, and if it is double equal to, it's a relational operator. It is going to compare whether the two values on the left and right of it are equal or not. And ultimately we have not equal to. In mathematics, we obviously write it this way: not equal to. When it comes to Python, we put an exclamation symbol followed by equal to. It means not equal to symbol. So I believe you got the concept of this relational operators. Different relational operators can also be used. And yes, and then we have the logical operators, and you can see the logical operators. There are three types of logical operators which can be used in a test expression. Logical operators are basically used to join the different relation. The different relationship can be joined using this logical operator. I'll give you an example. You need not worry so much. So first one is and, the next one is or, the third one is not. Now, and means it is used to check whether multiple conditions are all getting satisfied or not. And or means either of the conditions, one after the other, is getting satisfied or not. And not is basically used to negate the logic. It is just to make the logic just simply opposite. Now, we are going to see a few examples, related to logical operators. Then the concept will be very clear. Okay, now let's go through this particular program. On the right hand panel, you can see the program which I have written. Here, first of all, I accept two values, A and B. That is two numbers. In this case, I accept two numbers. And here, look at this if statement and how I used or applied the AND operator over here. Let me highlight this. AND is the logical operator. And we are going to check whether both the variables and B are greater than 50 or not. If both the content of the variables A and B are greater than 50, then it's going to display the message both are greater than 50. If either of them or both of them are not greater than 50, it's going to print both are not greater than 50. Okay, let's try. I believe you understood how to use the logical operator. Now let's try executing this particular code. Okay, the first message we got over here is enter two numbers. Okay, let me enter two numbers, say 56 comma say 76. So in this case, naturally both A and B, A is obviously 56 and B is obviously 76. In both the cases, they are greater than 50, and therefore it's going to definitely print both are greater than 50. Okay, now let me try something else. Let me run once again and try giving a different value. Say for example 12 and the other one is say 67. So one is greater than 50, the other one is not. So it's giving you the message which is written in the else block. Both are not greater than 50. So from here, in a nutshell, we can tell that AND logical operator ensures that only when both the conditions, or you may have multiple conditions also, if all the conditions get satisfied, only then it is considered that the entire test expression is getting satisfied or resulting to true, and only in that case the if block gets executed. And if either of the condition do not get satisfied, that means all are not getting satisfied, it directly jumps to the else block and it gets executed. That is how the entire AND works. So in a nutshell, the AND logical operator is used to ensure that all the conditions in a test expression get satisfied. Okay, now what we are going to do is we are going to check on with the program that is that uses or involves the logical operator OR. Let's see that. Okay, now we have the program that involves OR logical operator. I have simply substituted that and with or, and let's see the difference in the output. Now let me execute it, and upon execution, once again it gives me enter two numbers. Okay, let me put two numbers which are obviously greater than 50. So 65 and 87. So both A is 65 and B is 87, both are greater than 50. So it's going to print either of the number is greater than 50. So it's printing the message in the if block. That means if both the conditions are true, still the if block gets executed. Now we'll try one of them. Okay, let me execute. Now let me try, okay, 75, and this one is say 22. Now you see, still the statement in the if block gets executed. See, it's still printing the message either of the number is greater than 50. Now we'll try giving both the numbers not greater than 50. So let me execute once again. Say 12 and say 45. Now none of them is greater than 50. So in a nutshell, what happens with or, if either of the condition gets satisfied, then the statement or statements in the if block gets executed. If none of them get satisfied, only then the statements in the else block gets executed. I believe you understood this. Now we'll go for the last logical operator, that is not. And look at the not logical operator. Basically, not logical operator is used to negate a logic. It only works with a certain and this condition should be preceded with this not logical operator. Now here in this particular program, I input a number, and then what am I checking? If not a greater than 50. If not a greater than 50 means what? If it is less than or equal to 50. Not a greater than 50 means I am simply a greater than 50, I am making it opposite. That means a is less than or equal to 50. So that is what I was trying to tell you, that it is used to negate a logic. That is, it's trying to make the logic a complement of itself. So not is basically creating a complement of the logic, and then you might wonder, then what is the point in doing this? We could have interchanged the statement in the if and else block and still it would have worked. Yes, but sometimes we require to do that. It gives you a enhanced way of expressing your logic. Now you might think that you do not require this. Okay, not is a logical operator which is least used, no doubt regarding it. You can always do programs even without it, but let me tell you, there are situations where your code will look really nice and readable whenever you use this logical operator not. It is not always the case, but in certain situations we'll come across this in the later course. Okay, let me execute this program and let me put a number, say 45. And look at this, if not a greater than 50. Now this time it is going to get satisfied, because it is not true that a is greater than 50, because the number a is 45. Let me enter, and it is printing it is less than or equal to 50. That is, it's printing the statement in the if block. Now we'll try once again executing it, and this time we'll give a value which is less than 50. Say for example, we give I'll give a value which is greater than 50. Say for example 89. Now look at this. Now look at this particular statement. If not a greater than 50. Yes. If not a greater than 50, but a is greater than 50. So this particular if block will not get executed. The statements in the else block gets executed. So it's going to print greater than 50. Let's execute this. See, it's printing greater than 50. So this is how the not logic may be used for negating a particular logic. Now let's get back to the remaining part of our discussion. Okay, now we are going to go for if-elif-else statement. Now please remember, there may be a situation where you might have a condition even with the else block. Like here you can see, look at the syntax. If we have the first test expression, if the first test expression results to true, the statement out here will get executed as written in statement 1. Now, suppose the test expression 1 do not get satisfied. So what will happen? It will directly jump to the else. In this case, else again have if. So we call it elif. And here it will check for test expression 2. And even if this condition is not satisfied, it will go for the next statement, that is test condition 3. And if it is satisfied, well and good, it's going to execute statement 2. And if it is not satisfied, it will go for the third. And this process will continue until it reaches the last one. So in the last we have the else block. That means if none of the test expression, if none of the conditions get satisfied, the statement in the else block The else will be followed by 2 colon. I just forgot that. In the statements in the else block gets executed if none of the statements in the if and elif block is satisfied. So the statement in the else block gets executed, and ultimately it will come to the first unindented. This is exactly same what we had learned prior to this. It will come to the first unindented line. That means after executing everything, it will come to the statement X out here, which I have written, and you can see it is unindented. That means it will get executed irrespective of either of this condition gets satisfied or not. Now remember, this is a bit peculiar. That is, if the first test expression results to true, it will obviously execute statement 1, no doubt regarding it, because the test expression 1 results to true. And if that is the case, it will not check the remaining part. It will directly come to statement X. So if this gets satisfied, it will directly execute this and then it will directly jump to statement X. So same thing happens. Suppose if the condition is not satisfied, it will jump to the second statement. And in the second test expression 2, which you can see referred to, if that gets satisfied, the statement 2 or statement 2, whatever the statements out there out here will get executed, and from here it will directly jump to the statement X. So whenever a condition gets satisfied, it will directly jump to the statement X. That means the first unindented line of code. And if none of them get satisfied, it will directly jump to the else. That means after completing checking with all the condition, it will directly come to the else part, execute the default statement, and then again it will go to the same unindented statement. So here is an example. Here what I'm doing is I'm taking a number as input, and after taking the number, what am I doing? I'm checking whether the value of that particular variable is greater than 50 or not. If it is greater than 50, we can print greater. Now suppose if it is not greater than 50, if it is not greater than 50, there are two situations. Either it is less than 50 or it is equal to 50. Now look at the next one. For the else, again I'm putting a condition. So I'll put elif. Elif stands for else if. So else, again I'm putting a check. If the value of a is less than 50, then it's going to display smaller. Now even if this is not satisfied, only then the else block gets executed and it's going to display equal. And after that, it's going to definitely display anyway will get executed. So this particular statement gets executed irrespective of any of this condition gets satisfied or do not get satisfied. I believe all of you have got this. If elif, so elif is basically used if your else again have a condition to be checked, and I have only used a single elif. You can have multiple elif, and remember in this if elif else block, if any one of the condition test expression gets satisfied after executing that particular block, it will exit from the entire if else if elif block, and it's not going to check for the remaining test expression. Once one gets satisfied, it will jump to the remaining part of the program, leaving or excluding the remaining part of that particular block. So this way it enhances the speed also. Writing if several times will always make Python repeatedly check, but there might be a situation where if one of the condition gets satisfied, I don't need to check for the remaining condition. In that case, you need to go for if-elif statement. Okay. Next, what we have is nested if, and nested if, the name itself tells you nested if means if inside another if. Nested means one inside the other. So here we have ifs inside another if statement. So here what do we have? Here we are taking a number as input, and here what am I checking? We are checking if the value of a is greater than 50 or not. If the value of a is greater than 50, then it comes inside this particular block, and inside this particular block you can see this entire block is indented. That means slightly pushed inside, and in this block we have one more condition to be checked. If a is less than 60, this is called nested because it is inside another if statement, and here it will check whether it is less than 60 or not. If it is less than 60, it's going to print it's between 50 to 60, and say for example it's not less than 60, so it will print it is 60 or more. That means if it is greater than 50, and say for example I input a number, say for example 75, so it will come over here. It is obviously 75 is greater than 50. However, 75 is not less than 60, so it will come over here in the else block of the inner if statement, and it's going to print 60 or more. I believe you can understand this. And similarly, if I give a number, say for example 45 over here, so what will happen? this condition is not satisfied, that is a is not greater than 50, so it will directly jump to the else part and it's going to print 50 or less. So that's the message you are going to display. So in a nutshell, what I want to tell you is you can always have if or any valid Python statement inside another if statement. However, if you have an if inside another if, we call it nested if. And we can also, let me tell you, we can also have a nested if inside the else block. Even we can also have a condition to be checked again in the else block. Even that will be considered to be nested if statement. Don't tell nested else statement. Okay, I believe you can understand the technicalities of using the nested if statement. Okay. So here, now what we are going to learn is something called the conditional expressions. Now, conditional expressions basically is used to, define a simple if-else statement in a very concise manner. Now, look at the first one. Look at the first one. If test expression, so if this particular condition, that is test expression, whatever condition you have over there, gets satisfied, so the statement 1 gets executed, and if it do not get satisfied, that is if the else block gets satisfied, if the test expression do not get satisfied, the statement in the else block gets executed, that is statement 2 gets executed. So how do we write that? We write statement 1, that means execute statement 1 if test expression results to true. Look at the way we are writing it. And if this test expression do not results to true, so whatever is there in statement 2, that means after the else block will get executed. Look at the way we are writing it. Slightly different from whatever we have learned. I've given an example also out here. If A greater than B, C equal to A, else C equal to B. Look at this written in a single line. C equal to A. So C will be A when, only when, if A is greater than B. Similarly, C will be B. When will C be B? When A is no longer greater than B. So if this condition is not satisfied, in that case, the statement in the else block, that means whatever statement, whatever you have written after else will get executed, and that particular value gets stored inside C. Now remember, you cannot do enormous huge calculations using conditional expression. Conditional expression is only used to write very simple small if statement. You cannot, you can always make complex statements, but that will be ridiculous if you try to do. Conditional expressions are basically used to make a very concise form of if else statement that involves only a single line of code if the condition gets satisfied, and similarly a single line of code if the else block gets satisfied. Like we have C equal to A if the value of A is greater than B, and C will be B if the condition is not satisfied. So a single line of code. If you have multiple line of code, then this is absurd if you use this. Now the second example, look at the second example. What do we have? If A is greater than 0, this is written in if else statement, print greater, otherwise it is print not greater. So the conditional expression that corresponds to this if else block is print. You see, I'm writing this print just once, and what will it print? It will print the word greater. It's going to print the word greater provided what? If the value of A is greater than B. So look at the way we have written over there. And it's going to print not greater when, if this condition do not execute to be true. So in that case, the statement after the else statements gets executed. So it's going to print not greater. So I believe you can understand how to write, the if else statement using this concise conditional expression. Okay, now what I'm going to do is I'm going to show you a very simple operator which is basically used with if statement, that is the is operator. The is operator is basically used to compare the memory location. Now, okay, let not me be too technical. Suppose I have a variable A where A is 12.3. So here we have a variable named A whose content is 12.3. And remember, I had already talked about this. A variable always resides in the memory. Which part of the memory? Of course, inside the RAM. And inside this memory, please remember, everywhere, wherever you are using the data to be stored, it will always have an address associated with it. Address means the location where this particular number with a corresponding name, that is in our case A, got stored. And this address can be read by Python using the inbuilt function called id. So let me write id of A. So if I write id of A, it's going to give me the address or the identification location of this variable A, in which particular, exactly in which particular location it got stored. So you can see it's giving me that particular location. It's always a positive integer. Please remember that 60121184. So what is important to us is not what is the number, because this number you cannot manipulate. You cannot, specify where to store. What is important to us is this number is taken care of by the entire operating system. So Windows is responsible for allocating the space where a variable will get stored. Not even Python. Python only uses, takes note of the empty space provided by the operating system and stores the data out there. So 12.3 has been stored in such an empty space, which Windows said that, or any operating system said that it's an empty space, and that is being referred by the name A, and id means that is the location where this particular variable got stored, that is 12.3 got stored. Okay, now what I'm going to do is I'm going to assign this value of A to B. So B equal to A. Simple as that. Now let me identify, or let me find the address of B. Have you noticed something? Even B refers to the same address location as A. Notice carefully. Even this one is 60121184. It's exactly same as A. So whenever you assign, a variable to another variable, both of them refer to the same memory location. Whereas if you have another variable with the number 12.3, now this will not be considered to be utilizing the same memory location, although the number is same. So here if I write id of C, it's not going to give me the same address. So it's giving me different. You can see over there 58147920. It's using a different memory location altogether. So even though when I print, suppose if I display the value of ABC, all the variables are going to definitely display the value 12.3. See, all of them are showing 12.3, but both A and B refers to the same memory location, whereas C refers to a different memory location. That is what we are seeing over here. You can see. Now, interestingly, the operator is used to check whether two variables refer to the same memory location or not. Now, if I write A is B, if I write A is B, so A is B means I'm checking whether A and B both referred to the same memory location or not. And in this case, it refers to the same memory location. You can see over there 60121184. And even for B, we have 60121184. See, it's giving me true. Whereas if I try this with C, A is C. Now since C has a different memory location, look at the ID of C, it gave me a different memory location. So if I do this, it's going to display false. So I believe you can understand the meaning of this is operator, which is generally used with if statement. We write it this way: if A is B. So it means if A and B refers to the same memory location or not, or in other words, A refers to the same memory location as B is referring to, or B is referring to the same memory location as A. In that case, it results to true, otherwise it will result to false. So I believe you understand the usage of ID inbuilt function as well as the is keyword. Okay, now let me tell you, we can also use the logical operator not to negate the usage of the is operator. I'll give you an example, the same example. Let me continue. 12.3 and B is referring to A, that means it's referring to the same memory location, and C is referring to again 12.3. And this time what I'm going to write is I'm going to write A is not B. Look at the way it's written. A is not B. So A is not B, but A is B, and here if I write not B, that means it refers to a different memory location. So in this case, what it is going to result is false, because it is referring to the same memory location. And similarly, when I write A is not C, again the same thing is going to happen. A and C are referring to the same memory location, but here not is going to negate it. That means it's going to make it think that it refers to the same memory location, therefore it will result to true. So I believe you understood the usage of not with the is operator, and very important is we write the not operator after the is statement to negate it. So please remember that we don't write not is. Generally, that is what we do with the if statement involving relational operator. All the condition is preceded with this not, but when it comes to is should be succeeded with not. So that is how we write. Anyway, thank you. I believe today's the entire program, I believe you understood, and even this time it will be followed by assignments, and I believe you can solve the assignments and post it as soon as possible. Thank you.